This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyer, Space Coast News Editor. For 2 weeks, NASA's investigation team for DART, the Double Asteroid Redirection Test, have been studying data to determine if DART's kinetic impact with its target asteroid Dimorphos successfully altered the asteroid's orbit. DART's collision with Dimorphos marks humanity's first time of purposely changing the motion of a celestial object and the first full-scale demonstration of asteroid deflection technology. Here is NASA Administrator Bill Nelson to give us the results of that test.
2 weeks ago, NASA made history once again. We conducted humanity's first planetary defense test. And we showed the world that NASA is serious as a defender of this planet. And we captured the attention of millions of people around the world in this test. And that's because DART, as we call it, it felt like a movie plot. But this was not Hollywood. Last November, just before Thanksgiving, a Falcon 9 carrying NASA's first planetary defense test mission launched from the Vandenberg Space Force Base. And after a 10-month journey, millions of miles, NASA successfully crashed a refrigerator-sized spacecraft into the asteroid Dimorphos, 7 million miles from Earth, and it came in at 14,000 miles an hour, and it was a bullseye. But why would NASA do something like this? Well, if an Earth-threatening asteroid was discovered, and we could see it far enough away, this technique could be used to deflect it. And so today, NASA confirms that DART successfully changed the targeted asteroid's trajectory. Now, how do we know that? Well, prior to DART's impact, it took Dimorphos 11 hours and 55 minutes to orbit its larger parent asteroid, Didymos. Since DART's impact, astronomers have been using telescopes on Earth to measure how much that time has changed. And now the team has confirmed that the spacecraft's impact altered Dimorphos' orbit around Didymos by 32 minutes, and therefore successfully moved its trajectory. In other words, DART shortened the 11-hour and 55-minute orbit to 11 hours and 23 minutes, and it moved it in another location. And that has been confirmed by the telescopes. It was expected to be a huge success if it only slowed the orbit by about 10 minutes. But it actually slowed it by 32 minutes. Dr. Lori Glaze and the DART team will explain more about how we confirm that. Now, this is a watershed moment for planetary defense and a watershed moment for humanity. And that's why it was fitting that DART was an international endeavor. Science benefits humanity. This is a unifying mission. And thanks to Italian Space Agency President Giorgio Sacoscia, I thank him for his partnership. All of us have a responsibility to protect our home planet. After all, it's the only one we have. And this mission shows that NASA is trying to be ready for whatever the universe throws at us.
Analysis of the data will continue to fully understand the impact and its results. Nancy Chabot, the DART coordination team lead from Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, said DART has given us some fascinating data about both asteroid properties and the effectiveness of a kinetic impactor as a planetary defense technology. The DART team is continuing to work on this rich data set to fully understand this first planetary defense test of asteroid deflection. So just like in the movies, an asteroid was moved by a spacecraft from Earth. Thank you for joining me. Remember each Tuesday to join David Denault for America's Return to Space, and join me every Friday for America in Space. From the Florida Space Coast, I'm Dawn Meyer, Space Coast News Editor for About Space Today.
Thanks for listening. Be sure to share our program with your family and friends, and follow us on Facebook. Join us each week for news and information on America in Space.